Solving rational functions by cross product. Okay. And here's an example. This is what we're going to work our way up to and do. Okay. This is a quick review lesson since you have been on spring break. We're going to solve problems involving the rational expressions. Remember, we're going to review on simplification. We need to find the LCD or LCM. Least common denominator is the same as the LCM, least common multiple. Find the LCD or LCM. You need to multiply every term on both sides of the equation by the LCD. Make sure to cancel out anything that can be canceled out. Solve for the variable. If it is a linear equation, okay, get all the variables on one side, constants on the other. If it's a quadratic, set your equation equal to 0 and factor. Be aware of, there's a good chance for extraneous solutions, okay? So when both sides of the equation are multiplied by a variable, the equation is transformed into a new equation, may have an extra solution. So check each solution in the original equation. Make sure your answer does not make the denominator 0. Let's take a look at this. We have 1 over x is equal to 1 over 4 minus x. What is our LCM? Okay, the least common multiple. And for this case, it is the x and the 4 minus x. We are going to multiply both sides of the equation by this, and then we get to cancel whatever's in the denominator with whatever's in the numerator, and then this gives us just our simple equation. 4 minus x is equal to x. 4 is equal to 2x, which means here x is actually equal to 2. And if you plug that back in, you get 4 minus 2 for your denominator of, would make that a denominator of 2. So it's good. There's no 0 there. You would just have 1/2. All right, what's the LCM of these numbers? So 4 is 2 squared, 8 is 2 cubed. Notice the 12 is 2 squared times 3. So that means that the LCM is 2 cubed times 3 for 24. So you're going to multiply both sides by 24. You'll do a lot of cancellation. Remember, this is going to go into 24 6 times. So you're going to have 6 times the 3. And then the 8. So you get 3 times the 5. Okay. And on the right side, it's just 24, 12. You'll just get a 2x instead. Okay. And that turns into 33 over x. What's our LCM here? That's right, it's x plus 1 and x. Again, you can multiply both sides, cancel out what you don't need to get rid of the denominator, and then you're just going to solve for your x as a -2. Now, if you plug a -2 in there, notice again, your denominators do not turn to 0, so this is good. What's our LCM here? That's right, it's 2x. So again, we're going to multiply both sides by 2x. Okay, so we get 1 plus 2, and that's going to be equal to a -24x. Go ahead, divide by -24, so we get a -1/8 is equal to x. And again, if you plug that back in, none of your denominators are going to turn to 0. And let's take a look here. We just have an x. So now we get x squared plus 1 is equal to, we do have a 2x on this side from up above. Okay, so we get an x minus 1 squared, which x is equal to 1. Again, though, that doesn't turn our denominators to 0, so we're good. Okay, let's take a look at this one. Notice that these are the same. These denominators here are the same. So they would just cancel. Okay? And technically, your x is not only equal to 2, but it's equal to negative 2. But if we plug a negative 2 in there, notice that we're going to wind up with no denominator, a 0, because the negative 2 plus 2 is going to be 0. Okay? All right, cross products. This is a shortcut. Some of you have already been doing this. But instead of finding the LCD or anything like that, if you have where you just have the rational functions are just equal to each other, you don't have any more rational functions, let's say out here or over here, you can just do the cross product. Then you would do a distribution, and then what would our x be equal to? Okay, so our x would be equal to 10 in this case. Okay, it is not an extraneous solution, is it? All right, we're going to do cross products here as well. Okay, multiply the 2 through, and we just solve, and x is 5. We'll do our cross products here, and our x is going to be equal to what? Yep, it's a fraction, 17 over 2. Again, we don't have any extraneous solutions. Let's do this one. Notice that we get two quadratics. The nice thing, though, is that these quadratics, the x's are going to cancel. And thus, you're just solving for an x. And because of that, you won't have an extraneous solution either. Notice how our only extraneous solution showed up when we had an x squared that we were solving for. Yes, hopefully you find it that easy. Okay, that is the end.